Hi, everyone, and thank you for being here. So today I would like to talk about resources and how to manage them easily using Cat's effect as well as the Scala standard library. So my name is Julien Truffaut. I'm a Scala developer for a long time, and I also teach Scala and functional programming at fptower.com if you want to check out my course. I also co-founded scalajobs.com, which is a job board and also that offer full recruitment services dedicated to the Scala job market. So if you're either looking for a job or hiring, don't hesitate to check out our website. Because what's quite unique about us is that it's a project run by Scala developers, so people just like you. So we really understand the market, but we also understand the technical difficulties and challenges specific to Scala. And we try to grow the community. We offer free training materials to junior developers because it's difficult to start your career. We publicly advertise our clients so that you know who is doing Scala. So really, don't hesitate to give it a try. Now, advertisement is over, and let's talk about resources. So first of all, what's a resource? A resource is something that has three phases. Phase one is the initialization, when we want to set it up. Phase two is the usage, where we just use what we previously created. And phase three is the most important one, is the finalization. And the finalization is essentially some sort of post-processing operation, something that needs to be done once the resource is no longer required. So I came up with 4 examples so that we are all on the same page and we really know what's a resource. So example number 1 is really the most typical one. It's a file. Why a file is a resource? Because in order to use it, you first need to open it, right? Then you're going to either read or write data into it. This is the usage. And at the end, you need to close the file. Similarly, an HTTP server, you first need to configure it, like which port are you listening, how are you going to respond to incoming requests, and then you need to start it. So this is the initialization. Then for the entire duration of your application, you're going to respond to HTTP request. This is usage. And at the end, you need to shut down the HTTP server. So as you can see, there are lots of similarities between an HTTP server and a file. In my opinion, the biggest difference is really the duration. A file, it's typically going to be open for a short time. We open it, we do something, and we close it immediately. While an HTTP server is typically going to be open for the entire duration of our application. So it can be days, weeks. Also, we start to see why it's called a resource pattern. Because when you open a file or when you open a connection, you essentially acquire a file descriptor on your machine. And a file descriptor is a limited resource. It's something we don't have an unlimited amount of file descriptor. So if we open too many files or too many connections and we don't close them, eventually we don't have file descriptors anymore and we get an error. On the JVM, it's an I/O exception, too many files open. So in a sense, we are leaking resources as you can leak memory. It's very similar. Now I would like to show you 2 other examples that are more unusual. Third one is for integration tests. Most applications, they have a database. And if you have a database, it means you have like some kind of queries and you want to test them. But in order to test your queries, you first need to have a database. You need to create some tables. You need to maybe set up some test data. And you need to do all of this before your tests are executed. When you run your integration test, after each test or after the entire test suite, you want to clean up the data. So you want to probably truncate the table, maybe shut down the database, because you want to ensure that each test runs in isolation. We don't want one test to impact the result of another test, right? Similarly, this is probably the weirdest example of a resource, but you can think of a queue as a resource. And why a queue is a resource? Because the initialization is taking an element from the queue. The usage is somehow processing the event. And the finalization, here is where it's very different, is that if everything was fine, if your event was processed successfully, then we're good, nothing to do. But if something went wrong, let's say there was an exception, or the program was interrupted somehow, you probably want to do something with the event, because if you don't, this event that you took from the queue has been lost, and and it's probably going to be a problem. So typically what you want to do, if there was an error when you process the event, you either want to put it back into the queue, cool, thanks guys, or put it in another queue dedicated for errors, or you may want to put it in a database. But essentially what matters here is that if something went wrong, you don't want to lose the event. This is the key. This is a guarantee that we want to have. Either the event is processed or it's somehow put somewhere else. Does it make sense? Cool. Okay, so now to summarize, really the most important point with resources is to ensure that the finalization logic is executed no matter what. We want to ensure that we can't forget about it, because to be honest, we are the worst enemy. It's so easy to forget to close something, or even worse, you may not even know that something needs closing or finalized. You need to check the documentation and you don't necessarily know about it. But we also need to handle all these corner cases where an exception occurs or there is some interruption. So now let's have a look at a few solutions to solve this problem. Solution number one is a shutdown hook. And a shutdown hook is something from the Scala standard library. You can say sys.add shutdown hook, and you can pass a block of code, and this block of code is going to be registered, and it will be executed when your application shutdowns. And it's good, it can be useful for, second example, this HTTP server, because you can say, okay, at the beginning of my application, I create my HTTP server, I configure it, then I'm going to register a shutdown hook to close it when the application shutdowns, and then I can start the server. So it's quite convenient. Similarly for testing, pretty much all testing libraries offer some ways to run some code before and after each test or after all tests. So in Scala test here, there is this trait called before and after all. There is also before and after each that give us two methods, before all and after all. And we could use it for integration tests to create the table, put some test data, and so on. So really, hooks are really convenient, and I really recommend them. The main issue is that it depends on what you're doing. The API is not normalized. It's not it depends on, you will have one API for tests, one API for your application, so it's not the same. But also, you may not even have hooks available for the things you're trying to finalize. So to my knowledge, there is no hook for a file. I can't use one to say, I want to register and close it. So it's a good solution, but it's not a general solution. That's my point. Next, probably the thing that comes to mind when we talk about finalization and do something, no matter what, probably is the try-catch finally. Because the try-catch finally allows us to have these three code blocks, the try block that essentially you do dangerous stuff, the catch block that is optional that allows you to handle exceptions, and the finally block, this is what matters for us. It's a block of code that is executed no matter what. If it's for the failure, if it was a success, it runs anyway. So imagine the try-catch in your head. But one of the things that is a bit annoying with a try-catch finally is the fact that you can't access variables that you define in the try block. Because in the finally block, in order to access a variable, you need to have it defined outside. So that's why quite often you need to define a variable, you initialize it to null or none. And yeah, it works, but it's not a very the Scala idiomatic code. But it's okay. But to me, the most annoying point with try-catch finally is what happens when you have multiple errors. So again, imagine the try-catch in your head. Let's say in your try block, you try to open a file and read one line. What happens if the file doesn't exist? You get a file not found exception, right? Now, in your finally block, what we do is that we say your reader.close. But because there was an exception in the try block, the reader was never created, it's still null, and your finally code now is going to have a null pointer exception because there was an error in your try block. So you have essentially two errors, one error in the try block, one error in the finally block. So I have a question for you. Oh, nice. Cool, I can move a bit. It's here. So my question is here. What happens in this case? Do you get, at the end of the try-catch finally, do you get a file not found exception, Do you get a null pointer exception or do you get something else? So I'm going to ask you to raise your hand. Be ready. If you think you get a file not found exception, can you please raise your hand? Okay, couple. If you think you get a null pointer exception, please raise your hand. Okay, a few more. And something else? No. Okay, so you guys are right. You get a null pointer exception. And it's probably not what we want, right? As a developer, if I have this code, I don't want to see that there was a null. I want to see what went wrong the first time. I want to see what was the root cause of the error. So what do we need to do in this case? So I had to use Stack Overflow because I didn't know the solution. So I'm going to show you what people show on Stack Overflow. It's complex. So I'm going to quickly run you through the solution. That we need to add another variable that is a throwable. And it's again initialized to null. And the trick here is to have a catch block that essentially the catch block does nothing except then storing the exception in this variable. Now then we have another try in the finally block around the close. And here is the custom logic. We say, okay, if there was an error in the try block, then we're in this case where there was two exceptions, and we kind of link these two exceptions together using this add suppress method. So it's a way to link two exceptions together. So you will see both in the stack trace, and then you can throw it. Otherwise, you just throw the error from the finally block. So as you can see, it's tricky to explain. Even if you know this thing, it's so easy to get wrong. And to be honest, the worst part of all of that is the fact that the noise is horrible. What I want to do as a developer, I want to open a file and read something, but I have to write all this code around in order to just make it work as I want. So that's why I really don't recommend to use try and catch finally, except if maybe you write some low-level code, maybe some libraries, but otherwise I would avoid it because I just think it's too complex and too low-level. But there is better in Scala. In the Scala standard library, in 2.13, they introduced something called using. And it's in the same package, the Scala util package, which is the same place where you find try, for example. And using is great. Like, here is the same code as I've shown you before with the try catch, is the same code with using. So here we have two parameters. The first one is how to initialize or to open the file. And the second parameter is a function that gives you access to the resource you previously created, and you do what you want to do with it. And that's it. This is going to be closed automatically, no close method. It's going to do it magically. And it will handle multiple errors. So if you have an error in your usage and an error in your close, it's going to do the right thing. It's going to link all the code I've shown you before. It's going to do the same thing. So big win. It also, what I like is that it returns a try, as you can see at the end. So here this code doesn't return a string, but a try of string. And I don't know if you're familiar with try, but essentially it's something like an option or an enumeration. It has two possible cases. It's either a success, and this will give you back the string, or it's a failure that contains the exception. And I think it's good because when we work with resources, we know that something can go wrong, and we know it's quite common. And returning a try forces you to handle the case where something can go wrong. You need to pattern match on it. Similar to how options are better than null, I think it's the right decision. Other things with using is that it can manage multiple resources. It needs a different constructor, but it works. So here it's like using .manager, and this time we get a function called, I called it register. This function does nothing, it doesn't change anything, but it's a way to register a resource so that the internal of using knows that it needs to close this thing. That's mainly what it does. And then you can write all the code you want here, and then it's going to close all the resources automatically, and it does this in reverse initialization order. So here I first open the file to read and then the file to write. It's first going to close the file to write and then close the file to read. Doesn't matter too much, but generally it's a good pattern because you may have resources depending on one another, so you always want to do it in the reverse order. So again, using, it's nice because it does what we want automatically. Now, I said that using closes this resource automatically, and it's magic. Magic is cool, but debugging magic is not cool. So it's quite important to understand a bit what happens behind the scene. How does it close stuff? And it does it thanks to this constraint here. You see that the type of the resource need to have an instance of the type class releasable. And releasable is a trait that has a single method, release, that takes the resource and does something with it. So it's very like a closed function that you can find in like for a file or a connection. And what's nice with releasable is that the guys who implemented it, they implemented an instance of this type class for all autoclosable. And autoclosable is an interface from Java, and all files, connections extend this interface. So that's why you can open a file and close it automatically. It's because it has this autoclosable inheritance. But if you want to create your own resource and you want to be closed automatically, you will have to define this releasable interface, right? But you don't necessarily have to do it with an implicit, because in Scala, and this is one of the particularity of Scala versus Haskell, is that implicit can also be passed manually if we want. So potentially, let's say if you want to write this integration test with a finalization logic. So here, for example, the initialization, I'm going to open the connection to my database, create the table, then I'm going to run all my tests. And at the end, I have this extra code block because here I'm passing manually the normal implicit values. And here I'm telling you what do I want to do to shut it down. And so this is in Scala 3. I don't know if you're familiar with Scala 3, but they introduced this keyword called using. And this is where it starts to be a bit confusing because using in lowercase is a keyword of the language, while using in uppercase is this concept for resource. So if you're a bit confused, but it's unfortunate consequences, but yeah. In Scala 2, you don't need this lowercase using, but in Scala 3, whenever you pass an implicit argument, you need to put this keyword, but that's it. So to summarize, I think using is great. It takes a pattern that we need to do quite often, and it makes it simple. It does the right decision, so really I recommend using it. But it also has some limitations that I would like to highlight. The first one is that the release method doesn't give us any information regarding the execution of the process. So we don't know if it was successful, or we don't know if it went wrong. To be honest, most of the time we don't care. Generally, our finalization logic does something no matter what, the same thing, but sometimes it's important. So it would have been nice if we had some kind of extra information to tell us, was there an exception or was it good? Most of the time we do nothing with this data, but it would have been nice to have it. But it's okay. The biggest drawback, in my opinion, is the fact that using doesn't work with asynchronous logic. And I have an example for this. So imagine you want to make an HTTP request. So you want to create your HTTP client, assuming that it's a resource, and then you're going to make your HTTP request. This most of the time gives you like a future, and as you probably know, a future does the operation in the background. Like it submits the work in a thread pool, and the work is being done somewhere else. But the futures returns immediately, right? But here's a problem, because using is designed so that when you finish your usage block, so when you return a value, using assumes that you're essentially done with the resource. You don't need it anymore, and you can shut it down. But that's not true with asynchronous logic. You should shut down the HTTP client when you get back the response, not when you start it. So here's a problem, because essentially it's going to shut down the client even though we're still waiting for the response, which most likely will lead in an exception. So that's for me the biggest limitation of using. So now, as the talk suggests, we're going to talk about resource from Katz effect. So I put the code you need to put in your SBT project to import it. And the particularity of resource is that it's a type. So as you can see here, I define a function file to read to open a file to read. And the return type of this method is a resource. And I think it's nice because it documents the fact that the return of this requires finalization. So it's a good documentation. I don't need to check anything. It's visible in the type. And hopefully, the only way to use a resource is going to be safe. I'm going to show you that next. And here you see it's a resource of a reader. So it tells you it's a resource of something. And how do we use a resource? I'll show you later how to create one, but I think it's more important to see how we use it. So assuming we have this function, we're going to use the method use that will give us access to the resource being managed, the reader, and then we are going to read a line. So it's very similar to the code we've done with using. The main difference is this IO here. So I don't know if you're familiar with IO, but IO is also something from Katz effect. You can think of it as a lazy value, it's like a program that you can execute multiple times. Now, it's quite divisive. I think in the Scala community, some people very like it, some people hate it, so it's quite political. But in this instance, I do think it makes sense. Because an IO can support both synchronous or asynchronous mode of operation, or it can mix both. So the fact that we use an IO here makes that resource is going to close the resource only when the IO terminates. And it doesn't matter if the IO executes synchronously or it executes asynchronously. It's only going to run the finalization logic when it's done, which is good. It was one of the problems we had with using. Also, when we work with resources, we know that errors are common, and the API for error handling with IO is great. So it's quite useful. Finally, IO handle cancellation. So what's cancellation is that you can think of, the typical example is like, let's say you want to make an HTTP request. So you'll say you call a URL and you say, okay, because maybe this server is not responsive, it may take ages to get a response, I may want to put a timeout. So you say, I want to put a 30 seconds timeout. And how it's implemented, this timeout, essentially you do like a race. So on one hand, you do the HTTP request, on the other hand, you have this timer, 30 seconds timer. And it's a race because the first one who come back wins. So if it's the HTTP request that do it within 30 seconds, it gets back the result, and we have it, that's good. But if it's the timer that wins, and essentially we run out of time, we get back an exception, right? But when there is this race, and let's say that the timer comes back and say, okay, time's up, we are done. We would like to stop the HTTP request because we know that this HTTP request is never going to matter because, anyway, we're not going to listen to it, we're done, we timed out. So we kind of want to cancel it because it's not required any longer. But if you use like a future, you can't cancel a future. There is no, at least a Scala future, you can't do it. But IO support this sort of stuff. So again, it's not something you necessarily need too much in our application, but it's nice that it's there. Now I would like to show you how to create resources. The API, there are lots of constructors, but the most common one is called make. And make takes two parameters. The first one is how to create the resource, and the second one is how to close the resource. And again, you need to use IO everywhere. It's annoying, but it has some good reasons. Now, we know that when we work with files, we've seen before, files are auto-closable. The finalization logic is always going to be .close, right? So they created another constructor in resource called from autoclosable, where you only need to pass a single parameter, and it will close the resource automatically. So now I put like side-by-side resource and using, and as you can see, the code is very similar. Yes, resource is a bit more verbose, partly because from autoclosable is longer than apply method, but the main difference is the IO. In one hand, you need to use IO, in the other one, you don't. But there are good reasons for it. So that's really the main difference, but otherwise, it's mostly similar. Resource also works, you can combine multiple resources together. And how do you do this? Well, how you do most stuff in functional programming, in Scala, you do a for comprehension. Simple. Now, because conciseness is also important, there is another, so this for comprehension is really the default way to combine resources. That's how I write my main method of my application. I have all these resources that I create, and then I execute them. But in this special case, where you have resources that don't depend on another, there is a shorter syntax. I just wanted to show it to you because I know many people like conciseness. There is this method called tuple. So you can put all your resources in a tuple, you could tuple on it, and it's going to do the for comprehension all for you. So you use it, you don't use it, but it's up to you. But then the code can look like that. So essentially you call .tuple, then you call use, give you access of your two resources, and then you have your code. which I think is fairly readable. Now, to me, the biggest advantage of resource over all the other solutions is the fact that it's a type. And because it's a type, it means that other libraries can create it for you. And I'm lazy. The less work I do, the better. So, for example, there is this library called HTTP4S that has, it's a library to create HTTP server, HTTP clients, and they have this kind of methods to the builder pattern. You say, okay, I want to create an HTTP server. I define which port do I want to listen. You configure it, and at the end you call .build. And .build returns a resource, and this thing is going to handle all the finalization logic of your server. It's all done for you. You don't have to know how it works. It just works. Same with Doobie. Doobie is a library to work with JDBC, so for database. And in order to execute a query with Doobie, you need something called a transactor. And this here I created an eCarry transactor. And again, I don't really need to know the internal. This tells me that this thing needs to be somehow finalized. You call the constructor, it gives you back a resource, you combine them together, and everything will happen as it should. Okay, so now I would like to show you one example, like this queue example that we've seen, I showed you at the beginning of this talk. But so far, all the solutions we've seen, we're not able to really implement it. Because here in this queue example, we want to do our finalization logic depends on the outcome of our usage. And I want to show you how we could do this with resource. So here I define a method called requeue on error. And this method is essentially going to take a queue, take an element from it, and handle the case when something goes wrong. And this resource essentially gives me the guarantee that either it's going to process the event correctly, or it will put back the elements into the queue. That's the guarantee that this resource gives me. And how do you implement it? You have another constructor. It's resource.makeCase. Previously we've seen resource.make. Here it's makeCase. And what's the difference? The initialization is the same, but the finalization logic is slightly more complex. Now we have two parameters. The first one is the element we took from the queue. And the second element is called an exit case. And an exit case, it's an enumeration from Katz effect that has three possible outcomes. It's either succeeded, so it worked, it failed, or it was canceled. And so this just tells you what was the outcome of the processing logic. And then you can use a pattern match. This is standard tool in Scala. And then we can say, okay, if the logic was successful, then we do nothing. It was successful, the event was processed, we don't need to do anything. But if there was an error, or if it was canceled, we want to put back the element into the queue. Does it make sense? I think it's quite readable. Now, I added a couple of extra methods. These are things that I won't do in production. I just did it for the sake of the demonstration, so some sort of println. So here I have this method eval_tap that allows me to essentially print the element that I'm pulling from the queue. And this onFinalize allows me to show what is the state of the queue once we're done. It's again just the sake for the demonstration. So now, for simplicity, I create a queue with integers. This integer is supposed to be events that your application process. I have some sort of business logic, again, very simple for the sake of demonstration, that is does nothing except that it will throw an exception if the event is 2. And I have this IO that essentially call requeue on error. So it's going to consume an element from the queue and call my business logic. So this consume one, essentially, it's a small program that takes an element from the queue, apply my business logic, and if something goes wrong, it puts it back. Yeah? And because an IO is just a value, you need to call unsafe run sync in order to execute the code. This is the way you say, please now do this. And now, once you call this, you can see processing 1, so meaning we took the event 1 from the queue, and the queue after the finalization is 2, 3, 4, 1 has been removed. Does it make sense? Okay, now let's see what happens if we do this several times. So in the IO API, there is this method called replicate, and it's just a way to repeat. It's like a for loop. You say, okay, do it several times. So here I ask it, please do it 3 times. So we can see processing 1, processing 2. And it doesn't go further because there is an exception after processing 2. And we can see the state of the queue. After processing 1 is 2, 3, 4. After processing 2 is 3, 4, 2. So 2 has been put at the beginning of the queue. This was exactly what we want. And at the end, we do get an exception because even though we've seen we had some logic to handle the exception, but it's not handling the exception in a catch, in a try-catch finally. It's more to have some finalization logic that depends on the outcome, but it doesn't catch the exception in any way. So if we do want to catch the exception, we have this method handle error with that allows us to do something in the error. Here I say that if there is an error, I just want to print it, but I don't want to throw it. And now you can see the outcome. So it's printed, and now we can see processing 1, processing 2, processing 3, and we can see the outcome of the queue that changes. So again, I think if you've never seen resources on I/O, this went quite fast. I think you might want to have a look at this again. But what I like with this is this splitting the queuing handling logic in the resource. And you may have several strategies. You may have another strategy that puts the event somewhere else in another queue, in a database. And then you have your business logic, this process method that doesn't really care about exceptions, that don't care about what's going to happen if something went wrong. So it's quite nice to split these 2 concerns because it makes our code easier to read and easier to test, which is something that generally we want. So to summarize, what is a resource? So it's a general solution to do some sort of finalization logic. You can use a resource for anything. It supports synchronous and asynchronous execution because of this I/O. It has tons of utility methods and constructors for all the concerns you may have. I've only shown you a few today. Most important point, third-party libraries expose resources. So especially if you work in the type-level ecosystem, most of type-level libraries will create resource for you, so you don't have to care about it, you don't have to know how it works, it just works. But the main drawback, because I have to be honest, is that you need to use an I/O-like effect. It doesn't have to be an I/O, it could be Monix, it could be Zio, but it has to be something that behaves in the same way. So if you don't like this, or somehow your company has some policy to say, we don't want this crap, then yeah, that's not going to work for you. That's also why I kind of wanted to finish this talk with a way to guide you which tool should you use depending on where you are. So in my opinion, the biggest factor is, what tech stack are you using in your project? So if your tech stack is like vanilla Scala or you use Akka, then probably a mix of shutdown hooks and using is probably going to be a good fit. It has some limitations as we've seen today, but it's simple. It doesn't require external libraries and it works in 99% of cases. So I think it's a good approach. If you bought into the type-level ecosystem, you use several libraries from this, then resource is nice because you don't need an extra library, you already have it in your path. And these type-level libraries are going to offer resource for you, so you get all the benefit. And if you use Zio, so Zio is another kind of ecosystem, functional ecosystem, they used to have something called zmanage, which was the same as resource. But now they came up with something called scope. I don't really have time to talk about it. I just wanted to say, if you use Zio, Google it, check how it is. That's kind of the way they do it. So thank you, everyone. And do we have a couple of minutes? Do you have 1 minute? Okay. I just have one last thing I would like to say before I leave. Just like a way, I want to finish this talk as an opening questions. One thing that all the solutions I've shown you today have one limitation. And this limitation is that you only get the result once everything is done, when all the element has been processed and the finalization has been done. But it can be a problem. Let's say you open a big file, like a big CSV, like millions of rows. You need to parse to read all the data before you actually see the result at the end. Same, let's say if you query a database and there has millions of rows, you will only get them out of your resource once it's all closed. And it can be problematic because it takes memory and you waste time because you could start working on stuff before. Also, potentially, if you have millions of rows and there is an error at the 990,000 row, you get an exception and you may lose everything you have seen before. So what is the standard solution when we have lots of stuff and we want to start working as soon as possible? Streams, right? We have parsers that streaming parsers or parsers that parse everything. And it's the same with resource. There is this library called FS2. And again, it's an amazing library, and I don't have time to give it a proper introduction. But an FS2 stream, you shouldn't confuse with a stream from the Scala standard library. But it's really the same as a resource. And you can think of a stream from FS2, or you may think of a resource as a special case of an FS2 stream. Because an FS2 stream can have 0 values, 1 value, this is like a resource, many values, or an infinite amount of values. And what's very nice is that this FS2 stream, they have finalization logic built in. So they guarantee you that whenever you're done with your stream, either because you processed everything, or you stopped processing it, you just took the first 10 elements and you're done, or there was an exception, or it was canceled, or whatever, they guarantee you that when you're done, the finalization logic will be used. So really what I want to say is that if you have these concerns, that you want to use something that requires finalization, but you want to start working as soon as possible on the data, then check FS2 stream. That's it. Thank you, guys.